1.6 is piecewise functions. So just as a definition, a function is defined, a function defined by using two or more intervals. So intervals are always in the x. So if you're using two or more intervals, the function now becomes a piecewise function because it's two different functions, or two of the same functions in one function. Resulting in two or more pieces of functions, similar, different, doesn't really matter. So we're going to start by graphing piecewise function. Then we're going to go into creating an equation of a given piecewise function. And then we're going to discuss the continuity in a piecewise function. You can graph it, you can make a table of values, you can do whatever you want. Okay? But I will try to show you what I think is the fastest way. Graphing. Okay. Again, you can make a table of values, worst case scenario, plan F, make a table of values. It's really easy to make a table of values to graph this piecewise function, even though you don't even know what a piecewise function is. If I just went like -1, 0, 1, 2, 3, 4, 5, let's say. If I'm plugging in -1, obviously I have to plug in -1 only where I'm allowed, which is in that first function. I can plug in -1, plot a point. 0, plot a point. 1, plot a point. 2, no. I can't plug in 2 over here because this interval does not include 2. This interval includes 2. So I'm plugging in 2 over here, 3 over here, 4 over here, dot, 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 dot. I can graph my piecewise function very easily with a table of values. Okay, but you shouldn't have to use a table of values if you know how to graph the functions. X squared is just a parabola, so you can just graph your parabola as you should know how to graph it, right? Step pattern. Up 1 over 1, up 1 over 3, or sorry, up 3. And this is less than 2, so I'm just going to graph it this way for a sec. Kind of a guess. And I'm going to graph it this way. I'm going to mirror that point. And I'm just going to graph the whole thing at first on purpose. So this is just x squared, simple parabola. But because it only exists when x is less than 2, it can't be over here. And to notate that it's not equal to 2, at that point, I actually end it with an open circle. Okay, that means it's not equal to 2 on that line, or on that curve. So I just graphed that first piece of the function right here. Done. (2x plus 3), that's a complete joke. That's a grade 9 line. I can start at the y-intercept, which is 3, and then I can go up 2 over 1, up 2 over 1. And because I'm starting at 2, this is where I start drawing my points. Right? I start at the y-intercept because that's where I like to start sometimes to graph a line. But I don't put a dot until I'm in the interval that it dictates. And because it's equal to 2, I start with a closed circle. Now I continue my slope, up 2 over 1. I only need 2 points to graph a line. So I connect them. And I make sure I put an arrow only in one direction because it goes to positive infinity. This is greater than 2, so it goes to infinity. And that's it. That's my piecewise function. Yeah, I would have got the same thing if I did this. You just need to know open circles and closed circles, and these are existing at the same time. Another thing that you could have done instead of starting at the y-intercept, which is probably faster, is if I know that I have to start graphing it at 2, then just plug in 2 over here. 2 times 2 is 4, plus 3 is 7, so you're obviously starting it at 7, like really quick, right? You're kind of doing a table of values just once. This is a waste of time in my opinion, but sometimes I like to use single rows just to like kind of speed up my process. I don't like looking here. If I'm already here with my pen, then I'm going to start here and continue. Okay, I don't want to go back and forth. Okay, next we have to come up with an equation. Okay, could be tricky sometimes coming up with an equation of a piecewise function because some equations look like other equations. For instance, some people could think this one right here is an exponential function, okay, because it kind of looks like an exponential function, half to the x. Look, it's cutting by half. That's a 1, that's a half, it's going to go to a fourth, whatever it is, and keep going. The thing that helps me understand that it is not an exponential function is the visual asymptote. I'm approaching an asymptote. An exponential function is XER, right? It does not go kind of vertical. It kind of goes on forever, left and right. Okay, so this is actually 1 over x, and then this one's just a line. So how do we write this out? Well, use a black marker. F at x is definitely two functions. It's definitely 1 over x over here. Okay. And it's definitely whatever this line is. This is a horizontal line, so it's not, there's no x, sorry, there's no slope, so there's no x in my equation. It's just a horizontal line at 2. That's just a 2. Okay. And I only write a 2 because this is like f at x equals 1 over x. F at x equals 2, or y equals 2, horizontal line at 2. Now my integrals. It's 1 over x if, where is the stuff happening? Right here. 2 again. This is closed circle, so this is going to be if x is less than or equal to 2. Whereas this horizontal line has an open circle, so it's not going to include 2. If x is greater than 2. And done. I cannot have an open circle, a closed circle and a closed circle. That's not going to pass the vertical line test. That's not going to make it a function. It's not going to make it a function. A piecewise function is still a function. Okay? There's still got to be a unique y value for every x. Okay? So be careful there. There are going to be times where if you're graphing it, you might not know which to give the open circle to. You'll see in your homework. But in that case, it really doesn't matter as long as one of them has an open circle and one of them doesn't. Okay? You can't have two closed circles above each other. You might get questions where it's going to ask you about continuity. Is this function continuous? So when I say continuous, I mean there's no continuity over here. This is an asymptote. Okay? An asymptote is a type of discontinuity. There's no continuity over here. This is called a jump. Okay, so this is called a jump. And there's not even continuity over here. This is called a hole. Those are the 3 types of discontinuities. No other ones. Asymptotes, jumps, holes. Okay? I can even have like a line that goes on forever, and if it has a hole in it, it's not continuous at that point. Okay? I would call this more of a jump than a hole. That's why I'm making sure you know the difference. But an open circle is technically a hole. I don't have to graph this to analyze the continuity. Remember what I said over here, how to graph this too? If I plugged in this value, that was supposed to be at 7, even though it looks a little below. By plugging in the value of 2 and getting 7, I know right away that this is not continuous, because if I plug in 2 in this function, I get 4. So think of what I'm doing. I'm plugging in an x value, 2. In one of the functions, I'm getting 4. In the other function, I'm getting 7. Obviously a jump, just by plugging in that value. So what I want to do is I want to analyze at these guys, because that's where something's going to happen. Okay, that's where something's going to happen. So if I plug in 0 into this, I'll do it over here. I don't know where I'll do it. If I plug in 0 into this, I'm going to get 0 plus 1. That's a 1. If I plug in 0 into this, I get 1. Continuous at 0. So I plugged in the x value of 1. I don't even care how that function looks. I'm not even considering how the function looks. It's a waste of brain power. Just plug in a 1 into one function, plug in a 1 into the other function. If they're not the same y value, you know it's discontinuous. If they're the same y value, continuous at this point. So far I know that it's continuous. Now I'm going to test the 3's in the second 2 functions. So I'm going to plug in 3 into here. 2 times 3 plus 1 is 7. And I'm going to plug in 3 into here. 4 minus 3 squared is 4 minus 9 is negative 5. 7 does not equal negative 5. Just by doing quick little garbage, I know that therefore the function is discontinuous at x equals 3. Didn't have to waste my time graphing it, didn't have to waste my time making a table of values. All I had to do was plug in 4 things and do the easiest math that I can do. Continuous, same y value. Discontinuous, big jump. Big jump. Okay, I do want to talk about the absolute value of x. The absolute value of x, I don't have a second ruler, but it's okay. Looks like this, right? you can write the absolute value of x as a piecewise function. It's actually a piecewise function, whereas I have a line over here, y equals negative x. See that negative slope? And then I have a line over here, y equals x. And they both exist together, except in the middle is my interval. So on this side of 0, I have y equals negative x. And on this side of 0, I have y equals x. Together, it's a piecewise function, and we can call it the absolute value of x. But it's really just two lines. It doesn't matter what the slopes are. The absolute of 2x, okay, now it's like this, right? The slope's 2. It's negative 2 on this side, and it's positive 2 on this side. Same thing. Okay, so keep that in mind, the absolute value of x.